In this video, we are going to be showing you how to add a full digit 7-segment display to the project so that we know how much time it would take until the traffic light would change its color. So basically that's what we're going to be doing. I'm going to be showing you how to connect it all up to the Arduino and also show you the code. So without further ado, guys, let's get started. Okay, so now I'm going to go ahead and set up the circuit to put our 4-digit 7-segment display on the breadboard. But to run this, as you see, we have to hook up a lot of pins, so we have to use this shift register. I have videos about both of these, a video about the shift register and a video about this 4-digit 7-segment display. I have links down below in the description that is for both of these, so consider going to those videos if you want to learn more about these. So I'm gonna go ahead and connect up the shift register onto the breadboard. So I'm going to put it in right there. Okay, so then we're gonna go ahead and connect up all the power pins to this shift register first. So pin 16 right here, this pin, it's gonna be connected to positive 5 volts on the breadboard right here, like so. And also over here, as you can see, maybe you don't see right here, I've already connected up the ground and the positive pin to the breadboard over here, and I hooked it up over here so that the whole rail right here is connected to positive and negative voltage. And then pin 13, which is known as the OE pin on the shift register, will be going to ground on the breadboard. And then the MR pin, which is known as pin 10 on the shift register, will be going to positive 5 volts on the breadboard. And then the last power pin we have to connect on the shift register is the ground, which is pin 8 on the shift register. So I'm just going to connect it to the ground that is connected to the button. So now all the power pins are connected onto the shift register. And so the next pin we're going to connect is D6 on the Arduino to pin 12 on the shift register, which is right here. And then pin 7 on the Arduino will be connected to pin 14 on the shift register. And then pin 8 on the Arduino will be connected to pin 11 on the shift register. And that is all of the pins. Okay, so now we're going to go ahead and connect up the 4-digit 7-segment display onto the breadboard, like so. So then we'll go ahead and connect up all the digit pins that are responsible to provide negative power to each one of these digits. And when they do not have negative power, that means then that digit pin is supposed to be providing negative power to will not turn on. So the first digit pin that we're going to be connecting is D1. And this will be connected all the way to D5 on the Arduino. And then the D4 pin on the Arduino will be going to D2 on the 4-digit display. There we go. And then D3 on the Arduino will be connected to the D3 pin on the 4-digit display. And then the D2 pin on the Arduino will be connected to D4 on the 4-digit display. And so basically that is all of the connections connected to the Arduino. So now we gotta go ahead and connect all of the resistors to the shift register that need to be connected to this 4-digit display so that the shift register can provide positive power to each one of these segments to display a number. All the Arduino is doing with the digit pins is it's able to control which of these digits will be on. Okay, so this will be providing negative power to one of these digits to bright up the number, and the shift register will be controlling which number it will be brightening up on each digit. So now we can go ahead and connect up all of the resistors to their pins on the shift register. Okay, so pin 1 on the shift register will be going to the C LED on the full segment display, and then the second pin on the shift register will be going to the D LED on the 4-digit display, and you don't want the resistors to be touching. And then pin 3 on the shift register will be going to the E pin on the 4-digit display. There we go. And then pin 4 on the shift register will be going to pin B on the 4-digit 7-segment display, like so. So we're just going to kind of put it over the shift register. And then pin 5 on the shift register will be going to the A pin on the 4-digit 7-segment display. And then the 6th pin on the shift register will be going to the F pin on the 4-digit display. So I'm going to try to connect it, one right there. And then pin 7 on the shift register will be going to the G LED on the 4-digit display. So there we go. And so basically that is the circuit there. So connect that all up and then we will continue. Okay, so now here is the code. I'm going to be explaining just the updated code. Of course, if you don't understand all this code, go back in the past tutorials if you haven't watched them. It's important to go do that to see how everything works. So basically what we have done is we have started here with, we have latch pin 6, clock pin 8, and then data pin 7. So these are all the pins that we have connected to the shift register. Then we go ahead and come down here and we define these as well. These are the D pins on the 4-digit 7-segment display, which is pin 5, pin 4, pin 3, and pin 2. These are all the pins. It's important to have them all on the list so that we can easily access them. And then we have another integer which is also very important, which is called the rem time, which stands for remainder time. So this is for the remainder of time until the traffic light will change its color so that we can display that number onto the display. This will be holding how many milliseconds is left until we change the color on our traffic light. And as you see right here, I've also, just to mention this, I've changed these times significantly so that we can see the time changing, and right here, so the red will be on for 15 seconds. So then we come into the void setup and we go ahead and just define all the D pins. We set them all to outputs. That's what we do with this full loop. And so then we come here and we set up the latch pin, clock pin, and data pin all to outputs. And I set up the serial monitor because sometimes I do testing, but this is not very important. We can just go ahead and take this out. Maybe if you want to see some data and on the serial monitor, you would use it, but in my case, I'm not. And then we set up all the DP pins as high. So when we send them high, when it's a high signal, none of the digit pins can function because these are high and they have to be low, such negative power to be able to work. So then we come into the void loop and we have already done all this code, already explained it all, but it's this code right here that we have changed in this tutorial. And so I'm gonna go ahead and explain it. So the first thing is we do this part right here in the calculation right here, and it's millis minus last millis. This will give us how long we have been out of this if statement right here. And then we will subtract it by delays num, and this will give us the remainder of time that is left until we come into that if statement again. So it will put it in here, and so that's what this does right here. So now after all this, we have the remainder of time in milliseconds. So then we go ahead and we're ready to display this onto the 4-digit 7-segment display. So we'll go ahead and come in here and we do D pins 1 high. So this is the second digit in the row because we want our countdown to be in the center. So there's going to be 2 digits on the side that are inactive, they're not working. In the future, I want to do certain things with these, that's why we have connected them up, but we're not using them in this tutorial, but we will use them in the future. So basically, our first 3 this one high, meaning that we're not going to be using this, and we're going to be using number 2. Because what we're doing is we're trying to display the 10th place for the seconds. And we go ahead and we send latch pin low, saying now we're going to send information to the shift register. And then we go ahead and do the shift out function. We send data pin and clock pin, we give the function that. And then we do most significant bit first. And then we have digits, which is our array up here, which I haven't mentioned actually. This is very important. This array is what binary numbers that represents each one of these numbers. So this binary number represents 0, this binary number represents 1, and so on for all of these. So if you send the binary counter one of these numbers, it will display one of these digits on the display. So digits is holding all of this, and depending on what slot we are taking out of this digits will depend on the number we're getting. So let's say we chose 5. We're choosing slot 5. This would be slot 5 right here, and it will display the number 5. So you can see when we come down here, we have digits, remainder time, divided by 10,000 milliseconds. Since we are dealing with the 10th slot digit right now, we're trying to add a number onto that. We divide it by 10, and that will give us how many times 10,000 goes into remainder time. Sometimes it may be 0. If it is, then we will display 0. But sometimes it may be like 5 or something like that, then it will display 5. Of course, there will still be probably some number that will be left over, but we're going to take that number, we're going to display the leftovers on the ones place digit right down here. So we don't have to worry about the remainder of what we get from this right here. So we just basically display the number that we get here. This will give us an integer, not a float, so it won't be like 1.25 or something like that. It's going to be a whole number, a whole digit number, so that we can display it on the digits display. So then we go ahead and turn latch pin high, saying that we're not sending you more data. So then we come down here and we do remainder time divided by 10. So we just divide by 10 again, and we times it by 1000. This will give us the number that we essentially added to the display in milliseconds. Okay, we need that because the remainder time integer is holding all these values into milliseconds. So we have to have the whole number in milliseconds. Here, we're not doing milliseconds. We're putting them as integers. So we just times it by 10, and then we subtract it from remainder time and make it equal to remainder time. So essentially, we're just subtracting everything that we have displayed onto the 10th place digit on the display. So then after that, we go ahead and delay 3 milliseconds, just a short time, just enough for the number to light up onto the display for us to see it. And then we will go ahead and do digital write D pin 1 low, and we'll go ahead and turn the 10th place digit to high, making sure that we're not turning that one on. And then we go ahead and turn latch pin low again, and we do somewhat the same thing again, but we just divide it all by 1000 milliseconds, because now we are in the ones digit now, and so we are displaying the ones on the digit. So then after that, we did go ahead and turn latch pin high, and then we just subtracts remainder divided by 1000 times 1000 minus remainder time equal to remainder time. So basically we just subtract everything from the remainder time. And so in this case, there will be very little left over, but it's not essential for us to display that onto the display. And so then we just go ahead and delay 3 milliseconds, and we do this so quickly that essentially we will be not able to see that the segment displays are turning off, because our eyes can't see that it's turned off very quickly, and we'll be able to see the numbers of both of them together at the same time, changing as the time counts down. So basically that is the code. So now we can go ahead and see our project in action. Okay, so now here's the project, and as you can see, we have the 4-digit 7-segment display counting down, and as it counts down right now to 2, 1, and now it's going to go to green. And there you go, green is now counting down. Now green, it wouldn't stay on this long as usual, but I just want you to see that you can change the time, and that you can see the time counting down, and then once it counts down to 0, it changes. You may not be able to see green too well because it's kind of faint, but you can still see that it's counting down, and it will do that every single time. In the next tutorial, we're going to add 2 buttons on the side here, to where then we can manually change the time on here using this without actually having to put the times in the code. So basically that is the project. If you like this video, guys, consider giving this video a like. Also comment down below if you have any questions, and consider subscribing if you want to see more content like this. Thank you everyone, have a great day, bye.